Hello everyone, welcome to Sweetie Speaks official YouTube channel. Today let's learn about very interesting kind of processor which is called a superscalar processor. In case you didn't go through the previous video lectures in this series which is computer architecture, I request you please go through that first because you need to understand the pipelining concepts, pipelining hazards. Then it will be better to understand the superscalar processors. Let's get started. The first point in the superscalar processor is it can be considered as a processor, or I'll call it as a CPU, which implements instruction level parallelism. Now, if you remember, in pipelining, what we saw is we will execute multiple instructions together. But how? We are going to have different stages in the pipeline, and every instruction will be in the different stage of pipeline. But here, what we are saying, instruction level parallelism. It means multiple instructions can be fetched together. Multiple instruction can be decoded together. Multiple instructions can be in the same pipelining stage. That is why it is called a superscalar processor. We are going to see an example like how it works in the superscalar processor. But for now, you understand that multiple instructions can be fetched together in the CPU, which is superscalar processor. Another feature is that multiple instructions, why they are fetched together? Because there are different execution units where multiple instructions can be executed. They are dispatched to those units for execution, and all that can happen simultaneously. I'll give you one simple example. Say you have integer instructions and you have floating point instruction. And now what I am going to do, I am going to have a superscalar processor in which you have integer execution unit separate and floating point execution unit separate. So what I will do, I'll segregate the instructions into integer instructions and floating point instructions. Whichever is integer instruction, I'll dispatch it to the integer execution unit, and the other one, whichever is floating point, I'll dispatch it to floating point execution unit. This way, one integer instruction and one floating point instruction can be fetched together and they can like process together, right? So at a time I can implement two different instructions. I can complete two different instructions in one clock cycle in this example. Okay, so this way multiple instructions are dispatched to different units for processing, where different instructions are processed in different processing units. That's why they are completed together. It will execute more than one instruction in the same clock cycle. What is advantage of superscalar processor? We have seen that it will complete more than one instructions in one cycle. It means it has increased throughput. Throughput means number of instructions completed in a clock cycle. That will increase in case of superscalar processor. Another thing which happens in superscalar processor is you can avoid lot of hazards. Uh, in the if you go through the previous lectures, you will see a lecture on pipelining hazards where we discuss what are different type of pipelining hazards. We have seen examples and we have seen how to avoid it. What happens in superscalar processor? We avoid these hazards through judicious selection. We select it very properly. We judge it very properly how we are going to select and reorder instructions in such a way that there are minimal hazards, minimal dependencies. This happens in superscalar processor. Very judicious selection and reordering of instructions to avoid hazards as much as possible. Minimal hazards will be there. What is disadvantage of superscalar processor? We are going to add extra logic, extra hardware resource. Like we said, we want to dispatch different instruction to different processing unit. It means we are increasing the number of processing unit. We are increasing the hardware. We are increasing the design complexity. We are increasing the design efforts. which are required for this dynamic scheduling and dispatching logic. So we are in a way increasing complexity to get more throughput. Due to this, what happens? You are increasing hardware, so your cost will increase. You have more hardware, so the power consumption will also increase. Why the latency will increase? Because of complexity. Latency is time required for a single one particular instruction to complete, like from the start of the instruction to the end of instruction, how much time did it take? That is latency. That will increase because of this complexity. These are the disadvantages. Quick overview. What is a superscalar processor? It is a processor which implements instruction level parallelism. How does it do it? It has multiple processing unit and it dispatches different instruction to different processing unit. For example, I'll have the execution unit for integer separate, floating point separate. I'll put all integer instruction in integer execution unit, floating point instruction in floating point execution unit. So in one clock cycle, one integer and one floating point can complete. So two instructions will complete in one clock cycle. What is the advantage? It will have more throughput. We can avoid hazards because we reorder the instructions properly. What is disadvantage? It requires a lot of complexity and more hardware resources, due to which the cost and power consumption and latency also increase. Now let us see with the help of an example, let us understand how this superscalar processor works. So this is how it works. Here if you see, at the top I have the execution cycles and here I have instruction numbers. Let us see properly. Here if you see, in the first instruction is in instruction fetch. At the same time the second instruction can also be in instruction fetch. Take the example of that integer and floating point. Say this is an integer instruction, this is floating point instruction. So both of them are being fetched together. So both of them are being executed in parallel. Same happens with instruction 3 and 4. 3 and 4 both are in instruction fetch together. Same with 5 and 6. So if you see, in the fifth cycle, we are fully utilizing the pipeline. Everything is in pipeline. Okay, so this is where you are fully utilizing the pipeline. And in the fifth clock cycle, your instruction 1 and instruction 2 both are completing. In your sixth clock cycle, instruction 3 and 4 will complete. In your seventh cycle, instruction 5 and 6 completes. In your eighth cycle, instruction 7 and 8 completes. In your ninth cycle, instruction 9 and 10 completes. So at a time, two instructions are completing. Two instructions are completing in the same clock cycles. That's why the superscalar processor has more throughput. Now, I hope with this example you are clear what is a superscalar processor, what are advantages, disadvantages, and how does it work. To stay tuned to such creative and very, very interesting content on VLSI, please subscribe to Sweetie Speaks official YouTube channel. Thank you.